Almost always, by the time the image gets to a monitor, it'll be in RGB format because that's the format that the monitors use. So color spaces are a way of representing the colors in an image in a different way. And a lot of high definition video uses YCBCR. On the other hand, by the time the colors get to a printer, it'll be in CMYK format because that's the format that printers understand, and that's the color of their inks. RGB stands for red, green and blue, and apart from being the format we've talked about in the last few videos, it's also a format used by monitors. So if you want to show something on the screen, it's been basically put into RGB format. That's how much red have we got, how much blue have we got, and how much green have we got. When you add the colours together, you get different colours, and indeed, when you add all the colours together, you get white. Or if you take away all the colours, you get black. That's different to, let's say, the way that printers work, where if you add all the colours together, you get black, because if you keep adding colours in with your inks, you eventually get black. So if we draw a little RGB diagram here, so if this is red, and this is green, and this is blue, and halfway between blue and red will be magenta, between blue and green is cyan, and between red and green is yellow. And then between all three is white. And then outside of these, you've obviously got black. So you can create any colour you like on your monitor by varying the different amounts of these three colours. So on printers, it works slightly differently. So C, M, Y, and then K is black. But we don't tend to have K as part of this colour. We'll use it to just create black effects because it works better. Halfway between C and M is blue. And then halfway between C and Y, we've got green. And then between magenta and yellow, we've got red. And in the middle of all of them, unlike RGB, we've got black here. So we're going to put K for black because we've already got blue. So this works in a completely different way to RGB. So it's additive. So the more dyes we add, the darker everything gets. And then we use K to actually just print in black if we want to.
So even though there's not a separate round circle there on your diagram for K, you would have a fourth ink.
Yeah, because in practice, what you might find is that if you try and add M, Y, and C together to get black, in principle it works, but you'll end up with a kind of muddy dark brown ink, which is just not as good as just printing in black, and you're wasting a lot of toner doing that. So just print in black. The last colour space we're going to look at is YCBCR. Variants of it are commonly used in TV broadcasting. So for example, PAL uses that colour space, NTSC uses a similar colour space but slightly different, and a lot of high definition video uses YCBCR. What we're trying to do with YCBCR is separate the luminosity of an image, so the intensity of each pixel, from the actual colour. And by doing that, we can do all kinds of clever things by downsampling the colour and things that we'll get onto when we talk a little bit about JPEG. This is a picture I took of a flower, okay? And this is currently in RGB form. And if we want to split this into YCBCR, what we need to do is take away the grayscale and the colour and separate them. This is just the luminosity component, so this is just Y. And that essentially is a grayscale version of the image. How bright is each pixel? And then we've also got the CB and the CR components. So CB represents the kind of the chrominance, the blueness of an image. So in this case, some of the flower in the middle is blue and the background is kind of blue, but the actual flower is quite yellow. And then the CR is the redness chrominance value. So how red is it? And you can see it's actually pretty red, and the background is not very red at all.
So you mentioned the other one's sort of blue, but we're seeing obviously grey and yellow.
What I've done here is I've set the luminosity over the image to be flat at 0. And by doing that, the image isn't bright and it isn't dark, and we're just only seeing both CB and CR. So let me do a little bit of writing it down so you can see it better.
Yeah.
Okay.